Welcome back. Let's practice solving equations of the form x plus a equals b. All right, so here's our first example. We want to solve the equation and check the solution. And our equation is x plus 3 equals 7. Okay, so this equation is clearly in the form of x plus a equals b, or in other words, a variable plus a constant equal to another constant. And to solve these equations, our goal is to isolate the variable, or get the equation in a form where you have the variable equal to a constant. All right, and so to do that for an equation of this form, what you want to do is identify the number being added to the variable, in this case 3, and add the opposite constant or the opposite number to both sides of the equation. Because whatever you do to one side of an equation, you have to do the same thing to the other side in order for the equation to remain true and for the solution to remain unchanged. All right, so whatever you do to one side of the equal sign, you have to do to the other. If you don't do that, your solution will be wrong. Okay, so since our constant is positive 3, what we want to do is add negative 3 to both sides of the equation. Or essentially, we want to subtract 3. Okay, so what I'm going to do here is draw a line below the equal sign to help us visually see the two sides of the equation. I find this to be helpful when you first learn how to solve equations. You can always ditch the line later, but I like to show it early on. We're going to subtract 3 from both sides of the equation. And so simplifying, we have x plus 0 because 3 and negative 3 cancel each other out. 3 minus 3 is 0. That's the whole idea here of adding the opposite constant to both sides of the equation. It's going to cancel out with that constant being added to the variable, leaving you with just the variable, because anything plus 0 is just itself. All right, so we have x plus 0 on this side, but then on the other, 7 minus 3 is 4. So we'll write down 4, and then our final answer here is that x equals 4. All right, I put the equal sign back in once we have the variable by itself. X plus 0 is x, so we have x equals 4. That is the solution that we found for this equation, but what we want to do is check to see if that really is a solution to this equation. Does 4, when plugged in for x, make this equation true? Well, let's check it. What we're going to do is actually plug 4 in for x and see what happens. Do we get a true statement or a false statement? In this case, if we replace x with 4, we get 4 plus 3 equals 7. And simplifying, 4 plus 3 is 7. So we get 7 equals 7. That is a true statement. And so 4 is, in fact, a solution or the solution to this equation. Okay, if we got a false statement, if it said something like 6 equals 7 or 8 equals 7, anything that's not 7 equals 7, then you know that what you found is not a solution and you probably made a mistake somewhere and you need to fix it. It's possible you made a mistake when checking your work, so be sure to do that right. But assuming you did that check work right and you get an untrue statement or a false statement, you want to go back and check how you solved the equation because you made a mistake somewhere as your solution would not be correct. Okay, but in this case, we did get a true statement when checking our work, so 4 is a solution to this equation. Let's take a look at another example. This time our equation is y minus 3 equals 9. And so this time we have a different variable. It's not x but y, but that doesn't matter. We still have an equation in the form of a variable plus a constant equal to another constant. It looks like we're subtracting a constant, but that's okay. You can think of subtracting 3 as the same as adding negative 3. Okay, so this equation is still in the right form. And so what we want to do is identify that constant, in this case, negative 3. That's what's being added to our variable. And what we want to do is add the opposite of that constant to both sides of the equation. All right, so in this case, that would be positive 3. We want to add 3 to both sides of the equation to solve for y. So let's draw a little divider here. We're going to add 3 to both sides of the equation. And so that will leave us with y plus 0 because negative 3 plus 3 is 0. And then on the other side of the equation, 9 plus 3 is 12. So I'll write down 12, which means our final answer here is that y equals 12 because y plus 0 is y. All right, so y equals 12 is a solution to this equation that we found, but let's check it. Let's check to make sure that it is the solution. So on the side here, we want to check our work by plugging that value we found in for y in the original equation. Okay, so plugging 12 in for y, we get 12 minus 3 equals 9, and 12 minus 3 is 9. So we get 9 equals 9, which is a true statement, and so 12 is in fact the solution to this equation. Our work is correct. Next up, we want to solve the equation 2 plus a equals 10. All right, now initially this equation seems to be in a different form, but it is still in the form of a variable plus a constant is equal to another constant. It's just that the order of addition here has been switched, which is fine because remember from our properties of addition that the order of addition does not matter. So even though we have a constant plus a variable of a is equal to a constant, this is still in the form of an equation that we are focused on solving in this video, okay? Our variable is a, and we're adding 2 to that variable, and the addition of that constant and that variable is equal to a constant of 10. All right, so the process remains the same here. The number, or the constant being added to our variable is 2, so to solve the equation, to solve for a, we want to add the opposite to both sides of the equation. We want to add negative 2, or really what we're doing is subtracting 2 from both sides of the equation. All right, so if I draw a little divider here, we're going to subtract 2 from both sides of the equation, which will give us 0 plus a on this side of the equation, because 2 minus 2 is 0. And then on this side, 10 minus 2 is 8. So we get 8 on this side, giving us a final result of a equals 8. All right, so that is the solution that we found here. When a equals 8, this equation should be true, but let's check it. Let's check to see if 8 really is a solution to this equation. If we plug in 8 for a, we'll get 2 plus 8 equals 10, and 2 plus 8 is 10, so we get 10 equals 10, which is a true statement. Our work here is correct. Let's move on to another example. Here we have n minus 6 equals negative 1. For this equation, our variable is n, and the constant being added to that variable is negative 6, and n plus negative 6, or n minus 6, is equal to negative 1. All right, so what we're going to do here is add the opposite of this constant to both sides of the equation. So instead of negative 6, we want to work with positive 6. That would be the opposite. We're going to add 6 to both sides of the equation. So let's draw a little divider here. And then on both sides of the equation, we're going to add 6. Okay, so simplifying, we'll have n plus 0 because negative 6 plus 6 is 0. And then negative 1 plus 6 is positive 5. So we get 5 on this side, which gives us the equation n equals 5. And so 5 looks to be the solution to this equation. But let's check it. Let's make sure that our work is correct and that 5 really is the solution. We want to plug 5 in for n and see what we get. So we'll have 5 minus 6 equals negative 1, and 5 minus 6 is negative 1. 6 is 1 bigger than 5, so if you subtract 6 from 5, you do get negative 1. So our equation is negative 1 equals negative 1, which is a true statement. 5 is the solution to this equation. When n is equal to 5, the equation is true. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. Next up, we want to solve the equation 3 equals m plus 9. And so this looks a little bit different than what we've worked with so far, but this equation is still in the form of a variable plus a constant equal to another constant. It's just that the sides of the equation have been flipped. So we have a constant equal to a variable plus a constant. That is fine. Our process here is still going to remain the same. M is our variable, and you're adding a constant of 9. So to solve the equation, you want to add the opposite of that constant to both sides of the equation. All right, so in this case, we have 9, so we want to add -9, or in other words, subtract 9 from both sides of the equation. All right, so drawing a divider, we're going to subtract 9 from both sides of the equation. 9 minus 9 is 0, so on this side we get m plus 0, and then on the other side here, 3 minus 9, that would be equal to -6, so we have -6 on that side of the equation. So we're left with m plus 0, which is just m. Anything plus 0 is itself. So we get -6 equals m. That is a solution to this equation that we have just found. It doesn't matter that the order is reversed here. -6 equals m is the same as m equals -6. We do have an equation here that is in the form of a variable equal to a constant, so that is a solution. Okay, we're saying that when m is -6, this equation is true, but we do have to check that. Let's see if our answer is correct. Checking our work, we want to plug in -6 for m and see what we get. So we'll have 3 equals -6 plus 9. And simplifying, we still have 3 equals, but then -6 plus 9 is +3. So the equation is true. That is a true statement. 3 does equal 3, so -6 is the solution to this equation. When m equals -6, the equation is true. For our next example, we have an equation that involves fractions, specifically 5/8 plus x equals 1/8. We want to find the value of x that would make this equation true. So in this case, x is our variable, and the constant being added to that variable is 5/8. So to solve this equation, what we want to do here is add the opposite of this constant. So we want to add -5/8, or in other words, subtract 5/8. All right, so drawing a divider here below the equal sign, we want to subtract 5/8 from both sides of the equation, which will give us 0 plus x, right? 5/8 minus itself will be 0. And then 1/8 minus 5/8 would be -4/8, right? We do have a common denominator here, so we can subtract the two fractions. Specifically, you want to subtract the numerators, or the top of the fractions, and 1 minus 5 is -4. Okay? So then 0 plus x is just x, so we get x equals -4/8, but that can be reduced. That is not a fraction in its simplest form. Both 4 and 8 can be divided by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So really, this simplifies to be x equals -1/2. Okay, once again, I just got that by noticing that both 4 and 8 are divisible by 4, so we can reduce that fraction, and so we did. It's a good idea to get your solution in its simplest or most reduced form. Okay, so what we found here is that when x equals -1/2, this equation should be true, but let's check it. Let's make sure our work was correct. We want to check to see if -1/2 really is a solution to the equation. So we're going to plug in -1/2 for x. So we'll have 5/8 plus our value of x, which is -1/2. So we're adding -1/2, and that should be equal to 1/8. Now, in order to actually add these fractions, or really we're going to be subtracting because this one is negative, we need to have a common denominator. But as we just saw from earlier, -1/2 is the same as -4/8. So the work is already done for us. We don't have to try to get a common denominator. We already know how to rewrite -1/2 in terms of eighths. So we have 5/8, and then we're adding a negative fraction. So really we're subtracting that fraction. We have -4/8, and that should be equal to 1/8. And it is, because we have a common denominator here. So we can subtract the numerators, and 5 minus 4 is 1. So you get 1/8 is equal to 1/8. That is a true statement. And so -1/2 is in fact the solution to this equation. When x equals a negative 1/2, the equation is true. Okay, let's take a look at one more example for this video. All right, so here's our last example. We want to solve this equation. Negative 1/4 is equal to c minus 2/3. And so this equation is in the form of a variable plus a constant is equal to another constant. It's just that it's ordered a little bit differently. We have our constant equal to the variable, and then it looks like we have a variable minus a constant. But once again, you could think of it as adding a negative constant. Okay, so this is in the right form. And so our process remains the same. In order to solve for the variable, in this case c, we want to add the opposite constant to both sides of the equation for the constant term being added to that variable. In this case, that's negative 2/3. So what we want to do is add positive 2/3 to both sides of the equation. That will isolate c and help us solve the equation. So drawing a divider here, we are going to add 2/3 to both sides of the equation. And so on this side, negative 2/3 plus 2/3 is 0. So we get c plus 0. But then on the other side, it's a little bit more complicated because we're adding two fractions that don't have a common denominator. So we will have to do a little bit of extra work there. So I'm just going to write it down like this. Since it's not easy to just add these right away, I'll write it as negative 1/4 plus 2/3. Okay. And so now we can work on actually simplifying that. We do need to get a common denominator. We can't add these fractions without the denominator being the same. And this can sometimes be a little bit tricky, but if you're ever not sure what to do to get a common denominator, just multiply each fraction by a form of 1 that uses the other fraction's denominator. What I mean by that is, for this fraction we have 1/4, the denominator is 4, so multiply the other fraction by 4 divided by 4. That's a form of 1 because 4 divided by 4 is 1. So we are allowed to do that. But then this fraction's denominator is 3, so you want to multiply this one by 3 divided by 3. All right, so we'll multiply by 3 divided by 3, which is another form of 1. And by doing that, both fractions will have this same denominator because in both cases we now have 3 times 4 in the denominator, and that is 12. All right, so for this fraction, 3 times the negative 1 is negative 3. So we have negative 3/12 because 3 times 4 is 12. And then we have plus 2 times 4, which is 8. And that's also divided by 12 because 3 times 4 is 12. And so now we have two fractions that have a common denominator. So we can add the numerators. But before we do that, don't forget that we do have c on the other side of the equation. C plus 0 is just c. But then negative 3 plus 8 is 5. So we get 5/12 equals c. That is a solution that we have found for this equation. C equals 5/12. And so let's check to see if that makes sense. Let's see if 5/12 really is a solution to this equation. We want to replace c with what we found it's equal to, 5/12. So we have negative 1/4 is equal to 5/12 minus 2/3. All right. Now, in order to fully check this, we have to perform this subtraction, but once again, we have two fractions with different denominators, so we have to get a common denominator here. We probably want to get both of these fractions to have that same denominator of 12. I think that makes the most sense here. And we already found earlier that 2/3 in terms of twelfths is 8/12, right? We multiplied 2/3 by 4 divided by 4, we got 8/12. So that would be 2/3, but in terms of twelfths. Okay, so rewriting this, we have negative 1/4 equals 5/12 minus 8/12. And now that we have a common denominator, we can subtract the numerators. 5 minus 8 is negative 3. So we get negative 1/4 equals negative 3 divided by 12. You want to keep that same denominator. And right now it looks like we have two different values, but be careful. You want to make sure that both of your fractions are fully reduced. All right. Negative 1/4, that's fine. That can't be reduced any further. But negative 3/12 can be reduced. Both 3 and 12 can be divided evenly by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So what we get here is negative 1/4 equals negative 1/4. We get a true statement. Both sides of the equation are the same value, and so 5/12 is the solution to this equation. When c equals 5/12, the equation is true. Okay, so definitely a tricky one because of the fractions that were involved in the equation, but for all of these equations in the form of x plus a equals b, the main idea is the same. Identify that constant being added to your variable and add the opposite of that constant to both sides of the equation and simplify. Okay? But with that, this was the last example for this video, but if you do want to get some more practice solving these types of equations, I do have more on my membership site, so if that's something that interests you, feel free to look into becoming a member. You can find all the details for that on my website at jkmathematics.com/plus. That link will also be in the description of this video. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.